Now, we are going to start with the 11th numerical. This numerical is on angular contact ball bearings. Up till now, we were doing numericals of deep groove ball bearing, or we were doing numericals of rolling contact bearing. But now we are doing the numericals of angular contact ball bearings, right? So in angular contact ball bearings, let us see how to solve the numerical. Again, though it is angular contact, but it is a ball bearing. So obviously in our Bhandari design data book, A or P, whatever you write down, that is 3. Remember our formula, L10 is C upon PE raised to A or P. This load life relationship, this P or this A, whatever you say, that is 3. How did you know? Because it's ball bearing. That's why we are writing 3. But if it is roller bearing, then we are going to take it as 10 by 3. So single row angular contact ball bearing. C, dynamic load carrying capacity. C, right? So C is dynamic load carrying capacity or dynamic load rating. That is 53 kilonewton. So 53 into 10 raised to 3 Newton is used for axial flow compressor. The bearing is to carry a radial load, FR. Radial load is, FR is 2500 Newton. And axial or thrust load, axial load, thrust load, meaning is same, FA is 1500 Newton. Assuming light shock load during and determining the rating life of bearing. Rating life means they are telling us to find out L10. Rating life at 90% reliability, right? We are going to find out L10. So very quickly, they are telling us to determine L10 this time. Every time we were finding C, but this time C is given and we have to find out L10. So let's start. FA is given, FR is given, right? You can see FR is 2500, FA is given, but X and Y values are not given. So to find out X and Y values, you are going to refer this table, values of X and Y for dynamically loaded bearings in your design data book. But this time we are going to see angular contact ball bearings. That too, since the numerical is of a single row, we are going to see this table, the one which I have highlighted with red in color, this much portion. But if the numerical was of a double row, then I would have seen this table, this one. But for now, this is the numerical of single row deep groove ball bearing. So you have to do first FA upon FR calculation. Then you will come to know whether its value is greater than E or less than E. You can see our E value here, sorry, not the last one, 1.14. Since we are seeing this table, our E value is 1.14. So we have to check if FA upon FR is greater than E or FA upon FR is less than. In some books, FA, FR are written WA, WR. That's one and the same thing. So you can see FA is or WA is 1500. FR or WR is 2500. Once we do that, we get the answer as 0.6. The ratio turns out to be 0.6, which is obviously less than E. Right? So if it is less than E, we are going to see this column. We are not going to see this column. If it was greater than E, the value of FA upon FR, then we would have seen this column. FA upon FR is greater than E. But you can clearly see here, FA upon FR ratio came out to be 0.6. and it is less than this E value. You can see here, this is the E value 1.14 of single row deep groove ball bearing. So obviously, if it is FA upon FR is less than E, we will see this table. Now it is clear everywhere this is 1. So our X is 1 and Y is 0. So that's why we are choosing X is 1 and Y is 0 from the table. Nothing is mentioned whether inner race rotates, outer race rotates. Whenever it is not mentioned, we will take inner race rotates. We will assume that inner race rotates and we will take V as 1. Whenever inner race rotates, assumption is done, V is taken 1, and that is mentioned in Bhandari design data book also. Moving ahead. Now we have found out X, Y. We also have FR, FA, right? And this time they have told us that it is a light shock load. Light shock load. So for light shock load, you have to know that the S service factor over here, our formula of equivalent load is what? XVFR plus YFA into S or KA, whatever you write down, S or K is service factor. That light shock load, this is 1. I would suggest that remembering this table is not very difficult. So it's better if you remember this table, that if it is uniform and steady load, S is 1, light shock load, S is 1.5, moderate shock load, S is 2, heavy shock load, S is 2.5, and extreme shock load, S is 3. Here it is a light shock load. That's why we are multiplying here with 1.5. So obviously from table we found out X as 1. Inner race rotate assumption we have done. So V is 1. FR is given 2500 in the numerical. Y is 0. We found out from the table right now. Y is 0 and FA. So whole this thing will become 0. And this will become 2500. So 2500 into 1.5 is 3750 Newton. 3750 Newton. Now we have equivalent load. They have given us dynamic load carrying capacity in numerical. So if we have P, if we have C, if we have A, since it is a ball bearing numerical, we can easily find out L10. So once we put this value of C as 53,000, once we put this value of PE as 3750 Newton raised to 3, you will get the answer as 2823 million revolutions. Very easy numerical. Now, let's go to another numerical, right? So the next numerical is of a self-aligning ball bearing. Design a self-aligning ball bearing. Radial load is given FR 7000 Newton. Axial load is given FA 2100 Newton. This time life is given at 90% reliability. Whenever other than 90% reliability is there, that time you have to think whether what reliability is there. But whenever nothing is mentioned, whether it is what kind of reliability, you will assume that life is always at 90% reliability. Means 90% means L10. You're finding L10. So L10 is given this time 160 million revolutions. MR stands for million revolutions. At 300 RPM, N is given. N is 300 RPM. So this numerical L10 is given this time, right? So you will have to find out C, that is dynamic load carrying capacity or dynamic load rating. Uniform and steady load. If you see the previous numerical, I had told you that we take these values from this table, right? So this table, according to this table, uniform and steady load is 1. That's why we have written assuming S as 1. X and Y values are given this time, 0.65 and 3.5. Outer ring rotates. If inner ring rotates, we would have taken 1. But outer ring rotates, outer race rotates. That's why we are taking V as 1.2. Very quickly, let's start. We have to find equivalent dynamic load, PE, equivalent bearing load, equivalent dynamic load. It's one and the same thing. X, first let us take S. S is 1. Since it is uniform and steady load, S we have assumed 1. X is given in the numerical, radial load factor X is given in the numerical 0.65. Since they have told us outer race rotates, that's why we have taken V as 1.2. FR is given in the numerical 7,000. Y is given in the numerical as 3.5. FA is also given, which is 2100 Newton. Once you do the calculations, you will get the answer as 12810 Newton. Now, like I said, L10 is given, which is 160 million revolutions, right? C is to be found out. PE is 12810. Here you can see we just now found out this PE, right? So A or P, ball self-aligning bearing is a ball bearing. That's why we will take this as 3, right? So how the calculation will be done? This 3, when it will go this side, so the formula, the calculation will be 160 raised to 1 by 3. When 3 will go this side, it will become 1 by 3. Multiplied by, when this 12810 goes this side, it will go into multiplication. 12810 is equal to C. So once you do this calculation, you will get the answer as 69543.38 Newton. Very quickly, let's go to numerical 13. Single row deep groove ball bearing. Again, this is a numerical of ball bearing. So A or P in the load life relationship, that will be 3. Subjected to axial thrust, radial load is given 1200 Newton. Axial load is given. Axial thrust means axial load is given 1200 Newton. Radial load FR, that is 2400 Newton. This time they are saying that find the life, expected life at 50%. 50% of the bearing under complete condition. So L50 we have to find out. Life at 50%. But L50 is 5 times L10. So first we have to find out life at 90% reliability, which is L10. And then we will multiply it by 5. So we will get L50. Noticeable thing is that, guys, this is your numerical. Table is not given in the numerical. This is not given. Don't think that this table is given in the numerical. No, you'll have to go to page number 15.6. There you will find table 15.9, which is a table for finding X and Y factors of single row deep groove ball bearings. We have FA, we have FR. So we can find out what? We can find out our FA by FR ratio and X and Y factors. Now, 6010 is our ball bearing. I can find out FA by FR, but I cannot find out FA by CO. I do not have the CO value. Then what to do? In front of this 6010 bearing number, you can go to the table and find out CO value. Let's go and do that first, then find out the ratio. So this is the table of single row deep groove ball bearing, which is in Bhandari design data book, where you will find out SKF. Here is our 6010. Here is the CO value. Here are the C values, right? So, but if you see our 6010, Then in front of 6010, our CO value is 13200, while our C value is 21600 Newton. So we found out CO, we found out C. Now let's go and find out our X and Y factors. For finding out X and Y factors, you need to first find out FA by FR ratio. FA is 1200, FR is 2400, which is 0.5, which is higher than this E value 0.44. So you can say FA upon FR is higher than E, which is 0.44. You can see here 0.5 is higher than 0.44. So obviously we are going to select this table. We are going to take this table, not this table, because E value is less and FA upon FR value 0.5 is more. Now, since we are going to see this, that is understood that X value will be 0.56 because everywhere X value is 0.56. But which Y value you should take out of these? So for that, you have to find out FA upon CO ratio. FA is 1200. CO, we right now found out from the Bhandari design data book in front of bearing number 6010, that is 13200 Newton. Ratio turns out to be 0.09. Now, if you see these values, 0.09 exact value is not there, but 0.09 lies between these two values, which is 0.07 and 0.130. So we will have to do interpolation. We will find out the value of Y for FA upon CO 0.09 by interpolation. So what is the interpolation formula? Here it's written. Y1 minus Y2 upon X1 minus X2 is Y1 minus YR upon X1 minus XR. So let us first write down this X1 value of FA by CO, which is 0.070. And in front of that, what is our Y value? You can see here it is 1.6. So this will become our Y1. We have to find out what? Our FA by CO 0.9. In front of FA by CO, we want to find out Y value. In front of this 0.130 FA by CO, the Y value is 1.4. Now, we will simply name these as this is X1, this is Y1, this is XR, this is YR, this is X2, this is Y2. YR is unknown, and if you put all the values of Y1, Y2, X1, X2, Y1, X1, XR in this formula, you will get the value of YR, or say you will get the value of this Y. You will get the value of this Y, which is over here somewhere, which is 1.53. So X is 0.56, Y is 1.53. That we understood. Now let's go to completion of the numerical. Nothing is mentioned regarding the load, shock load. So we will take it as 1. We will take inner race rotates because for that also nothing is mentioned, whether inner race rotates, outer race rotates. We will assume inner race rotates, V as 1, and we will proceed. So S is 1. X we now found out from the table 0.56. V is 1. Here we have assumed it. FR is given in the numerical. Y we have found out from the interpolation formula. FA is given in the numerical. Once you do the calculation by BOD-MAS rule, remember while doing calculations, do keep in mind bracket of division, multiplication, addition, subtraction. First, you have to do division, then multiplication, then addition, and then you should do subtraction of the brackets. So guys, now let us start and proceed further. We have been told to find out average life. right? So for that, we will first have to find out L10 life. Our formula is L10 is C upon PE. C, we found out in front of 6010 SKF bearing number from the table. And that C value we had found out 21600. PE, we right now found out here, it is 3180. Raised to 3 because it is a ball bearing numerical, right? So when you do the calculation in your calculator, you will get as 313.38 million revolutions. We have to find out average life L50, which is 5 times the life at 90% reliability L10. So 5 into 313.8, 1567 million revolutions. So what is the practical meaning of this? The practical meaning is that when 50% bearings were working, when 50% bearing failed, right? Then at that time, the life of the bearings were 1567 million revolutions. The bearings had rotated or had taken 1567 million revolutions, after which they failed.